Today, we are reversing every other word in a string. We are finding the length of a missing array in an array of subarrays. We are playing around with matrix addition. We are creating a vector class. And then we are going in an upward spiral. Hello world, and this is episode number 30 of Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more difficult katas later in the episode. Today we are working with some katas featuring arrays. Starting with a non-empty array of integers, the goal of this kata is to return the result of multiplying the values together in order. Let's go ahead and get started with this one here. Const to grow, and we have our array of numbers here. And what we will do with those numbers is run those through, as the kata title suggests, the reduce method. Numbers.reduce. We have our accumulator and our number. And we are going to return, I think it is accumulator times number. And our initial accumulator is going to be set to 0 here. Let's go ahead and punch this into Codewars and see what this looks like here. Yeah, test this out here, and already we have a problem. Expected 0 to equal 6. Yeah. Okay, that... How about we start that initial accumulator at 1, actually. That's why we always call it the warm-up segment here. And we are good on that. Our next warm-up kata, we are given an array of integers as strings and numbers. Our goal is to return the sum of the array values as if they were all numbers here. Let's go ahead and give this one a shot here. Alright, const sum mix. We're going to have our integers array here. Our kata instructions suggest that our integers will be given as both numbers and strings. So what we will go ahead and do is, I think parse int can be run on a number as well. Alright, let's load up the node repo here and confirm our suspicions here. Parse int 20, let's do 12. Yep, it looks like actually our parse int does work on numbers here. With that being said, what we can go ahead and do here, we'll do the same thing we did in our previous warm-up kata here. Integers dot reduce. We'll have our accumulator here and our integer, and we'll do accumulator plus parse int integer, and we'll have our initial accumulator again as 0 here. So what parse int will do is, if this predicate function runs into a string instead of a number, this function will convert that string into a number. Now if integer is already a number, parse int will do nothing. So let's go ahead and punch this into Codewars and see what this looks like here. And we are good on that. Our next warm-up kata, we are given another array and a limit value. The goal is to check that all the values in the array are below or equal to that limit value. Return true if it is, false otherwise. Let's go ahead and give this a try here. We can assume that all values in this array are numbers here. Const small enough. We have our numbers and our limit here as our arguments here. And what we can go ahead and do, now this kata expects us to return true if all the numbers here are below this limit here. I think this is a job for the array objects every method. Alright, let's do this. Numbers.every. And in our predicate function we have our number. We return true. This predicate function will return true if number is less than or equal to our limit. And this predicate function will return false if this number is greater than our limit. And that will cause the every method to return false. And by extension, our kata function here to return false as well. Let's go ahead and punch this into Codewars and see what this looks like. And we are good on that. Our next warm-up kata, we are given another array, and the goal here is to return a pair of the highest numbers, the two highest numbers in that array. Let's go ahead and give this a try here. Const 2 oldest ages, and we'll have our ages here as our numbers array that we're passing in here. First, we are going to sort these ages in descending order. That is from highest to lowest. And we'll do that by doing this. Const sorted equals ages.sort. And for our sorting function here, we are going to return b minus a. This sorting function will make sure that our ages are sorted in descending order, with the highest two ages going first. And that should allow us to do this. Return in a destructuring assignment, sorted at 0 and sorted, or rather, sorted.slice. And we start from at 0 and we end at 2. Alright, let's go ahead and do a little console.log here to test this out here. 2 oldest ages, and we'll pass in an array 1, 2, 10, and 8. Let's test this out here. Node warmup 2 oldest. Oh, whoop, still on the repo here. Let's try that again. Node warmup 2 oldest. And we have the array of 10 and 8. Alright, let's go ahead and punch this into Codewars and see what this looks like here. Run the tests. And what has gone wrong here? Okay. Looks like this kata actually expects the second oldest age to go first. So what we can do we can actually do this in one of two different ways. We can do this sliced array right here and run that resulting array through reverse. Let's punch that into Codewars and see what that looks like. Whoops. Run our test here. What we can also do is the aforementioned destructuring assignment here. We can do this, sorted at index 1 and then sorted at index 0. And this should also work as well. And we are good on that. Finally, we are given a two-dimensional array of size m times n. The goal of this kata is to find the sum of the minimum value in each subarray. Let's go ahead and give this one a try here. And we're going to do const sum of minimums. And it's going to take our numbers two-dimensional array. And what we can do with each of these, what we need to do with each of these subarrays, we need to figure out the minimum value in each subarray, and then we need to sum those minimum values together. Now, we can do this again with the reduce method here. Numbers.reduce. We'll have our accumulator and our numbers subarray right here. And what we can do with the elements in the subarray, we'll do accumulator plus math.min, and then we'll go ahead and use the spread syntax to spread the numbers in the subarray into arguments in the math.min function. So numbers subarray. And again, we'll have our initial accumulator at 0 here. So what's going on here is we're running this two-dimensional array through the reduce method here. This predicate function iterates through each of the subarrays in our numbers array here. We take the minimum value of that subarray using the math.min method and spreading the numbers in that subarray into arguments of this function using the 3.spread syntax here. In so doing, I expect to see the sum of the minimum values of each of our subarrays that we pass into the numbers array. Let's go ahead and punch this into Codewars and see what this looks like here. Let's run the tests. And we are good. That concludes today's warm-up segment. I will see you in the next kata. Given a string, the goal of this kata is to reverse every other word in that string, discarding any leading or trailing white space and assuming that punctuation is a part of each word. Let's go ahead and give this one a try here. What we can do is, we can actually do this with one line here. First, we'll take the string and split it into its individual words using a blank space separator. Then we can run that resulting array through the map method. In the predicate function of the map method, we'll have a word, and we need the index of that word in the array as well. And what we can do is, if the index is an odd number here, we'll take the index, divide it by 2, and get the remainder. And if it's not 0, we'll go ahead and reverse that word here. So what we'll do is word dot split into its individual characters dot reverse dot join back together with each with a blank string separator. Otherwise, if the index is an even number, if index modulo 2 does return 0, we can just go ahead and return that word. Now we'll take that resulting array and join that back together with the space separator here. Now, before we do this, just before we do our split here initially, we need to trim our white space out. And we can do that with the trim method. Alright, let's go ahead and punch this into Codewars and see what this looks like here. Run the tests. And what's going on here? Because I did not call reverse here. Alright, let's try that again here. Run the tests. And we are good. Remember when we were using the spread operator during the warm-up katas? We can actually achieve the same thing with strings in order to get the individual characters from that string. Just place the 3 dots before the string variable to spread out and get the individual characters from that string. Try encapsulating that operation inside brackets, and you will get those characters in the string inside of an array, just like what we would do if we were using the string object's split method using a blank string separator. Given an array of subarrays, each one subsequently increasing length except for one missing array, the goal of this kata is to return the length of the missing array. Alright, let's go ahead and get started here. This sounds quite a lot like the arithmetic progression kata we did in the previous episode here, where we had to find the missing term in that arithmetic progression here. Alright, what we'll go ahead and do here, first we need to do some sanity checks here. We're going to do, first we need to check if the length of our array is a 0. Actually, we need to check to see if the array is null or of empty length. So, array.isArray, arrays is false, or arrays.length is 0, we'll return 0 up here. Now, what we'll need to do, let's first sort our array of arrays into ascending order by their length. And we'll do that by doing this. Arrays.sort, and our sorting function will have a and b, a.length minus b.length. So our arrays, subarrays, should now be sorted in ascending order by their length. Now what we need to do here, in a for loop here, we're going to do this. For let index equals 0, index is less than arrays.length plus index. And we need to keep track of our length differences here. Put that in an array here. All right, we're starting at 0 here instead of 1 because we also need to check to see if the length of each of our arrays is 0. So what we'll need to do is if arrays at index dot length is equal to 0, then we just go ahead and return 0 up here. Now, the rest of our for loop will execute if array is greater than 1. So if index is greater than 0, yeah, I said greater than 1 here, I meant greater than 0. Sorry about that. If our index is greater than 0 here, what we'll need to do is we're going to go ahead and do length differences dot push, and we're going to push into this array the difference between the length of this array and the length of the array at the previous index here. And we're going to need to pass this into math.abs. We want the absolute value of that in case we run into instances of then again, shouldn't be a problem because we're already sorting these arrays in ascending order. So what we can go ahead and do is arrays at index minus arrays at index minus 1. All right, well, this should give us the correct length differences here. Yeah, I noted in this Kata example, these arrays are not sorted here. So I just went ahead and sorted these in ascending order by their length, as I mentioned before. Now, what we should be able to do from here, we need to get to the minimum and the maximum difference in this length differences array. So what we'll do here is const min difference equals math.min. We're going to spread out these differences here, and we'll do the same here, max difference. We'll do math.max length differences. And what we should be able to do is return need to raise at max difference dot length plus min difference. I think that's right. Let's go ahead and test this out here. I'm going to grab this array from the Kata instructions here. We're going to do console.log get length of missing array. We're going to pass this array of subarrays in here. Let's test this out here. Node missing array length cannot read property length of undefined. Okay. Console.log arrays. Oh, right. We actually need to get the index of our max difference here. Const max diff index equals array, or rather length differences dot index of max difference. And then we do this, max diff index. Cannot read property length of undefined still. Okay, what is our max diff index then? -1. Okay. Okay, let's go ahead and log our length differences here. Not a number. That would be why. We were subtracting the arrays themselves and not pulling the lengths out of them first. Alright, that should do it. And that is the right return value here, 3. Let's go ahead and get rid of this console.log here. Alright, let's go ahead and try out some of these tests down here before we turn this in. How about this one? Looks interesting. How about this one here? This array of subarrays here. And I expect a return value of 5 here. And we do get that. How about an array of an array of nulls? No, and we expect 3, but we don't get 3. Alright, that's gonna be a problem. Alright, let's go ahead and console.log our length differences here. Oh, because in our arithmetic progression kata, we could safely assume that there were at least 3 elements in our array. Here we have to account for instances where there are only 2 elements here. With that being said, okay, I know how to fix that. If arrays.length is equal to 2, then we'll go ahead and now if the length of our subarrays array is 2, that means there is only 1 difference between the lengths here. So what we'll go ahead and do, return arrays at 0. Dot length plus min difference divided by 2. And that should give us our 2 here. And we'll have our else case here. Alright, I think this is gonna work. Let's go ahead and punch this into Codewars and see what this looks like here. Alright, we'll run the tests. And what is the problem here? We cannot read property length of null. Alright, we have instances here where We seem to have an instance here where we have arrays of the same size.
Indeed, the matrix returns 0. Now you can consider that one array is missing. It's an array.
Alright, we seem to have an issue where we are given an array of... Alright, let's go ahead and get rid of this console.log length differences here, and let's actually console.log our sorted arrays themselves here. Console.log arrays. Alright, let's go ahead and punch this into Codewars here and see what is going wrong here. Let's run our initial test here. Let's hit attempt. Maybe we need to check to see if that array is an array here. Try this. Array.isArray. Arrays at index. Is equal to false. Or just like we did at the top of our Kata solution method here. Let's punch this into Codewars and see what this looks like here. Oh, yeah, the problem is happening in our sort function here. So what I think we need to do is run another loop before. No, that... Okay, I have an idea. We'll do a ternary operator here. Check the validity of that here. Let's go ahead and try that again here. No, that ain't gonna work. Alright. Yeah, unfortunately doing that causes our Kata test to fail here. Alright, let's go ahead and... Yeah, looks like we might have to do this in a separate loop. So what we'll go ahead and do, we're going to go ahead and get rid of all that here except for our length differences here. Set our index to 1. Hate to have to do this, but it looks like we're doing another loop here. Const array of arrays. If array.isArray is 0 equals arrays false, or array.length is 0, return 0. Alright. Let's go ahead and punch this in and see what this looks like here. Whoops. I said let's go ahead and punch all this in here and see what this looks like. Alright, run the tests. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to my right here. We take the array of arrays and we check to see if it's a falsy value like null or undefined. If it is, we set it to an empty array. We then take that array and run it through the map method. And for each subarray in that array, we check to see if that subarray is a null or undefined or otherwise a falsy value. And if it is, we map 0 to the resulting array. Otherwise, we map to the resulting array that subarray's length. We then go ahead and take that resulting lengths array and run it through the sort method to sort it in ascending order. Next, we check to see if the resulting lengths array includes a 0. If it does, we return 0, otherwise we continue. Now we're going to iterate through each of the lengths in that lengths array. Now, what I was doing in our Kata solution was I was assuming that the differences between the array lengths could be a number other than 1, just like what we did in the arithmetic progression Kata in the previous episode. Turns out my assumption was wrong, and that the differences between these lengths would only be 1. With that being said, we check to see if the current length, the difference between the current length and the previous length, is a number greater than 1. If it is, we go ahead and return the length of that missing array. If we reach the end of this for loop without finding that missing array, we just return 0. Here we are doing matrix addition. Given a pair of square matrices, which will be represented by two-dimensional arrays, the goal of this kata is to return the sum of those two matrices as a solution matrix. Let's go ahead and give this one a try here. Actually, I have a little bit of familiarity with this one here. What we'll go ahead and do is we are going to go ahead and keep track of our result array. And what I think we'll need to do here, we're going to need to populate this one already here. We'll do new array. And I think we'll go ahead and... No, wait a minute, I have a new idea here. What we'll go ahead and do is, now we can assume that our two matrices are going to be of the same size. We can actually go ahead and try this. Const result equals first.slice. We're going to make a result of that first matrix here with the slice method. And what we'll go ahead and do is for const for let in I equals 0, I is less than first dot length plus I, for let j equals 0, j is equal to is less than first at I dot length plus j. And then what we'll go ahead and do is we're going to do result at I at j plus equals second at I at j. And we're going to go ahead and return that result here. So let's explain what's going on here. We have our matrix addition function here, and we have our first and second matrices here. We take the first matrix and make a copy of it using the slice method, and we store it inside our result here. We first iterate through the subarrays of our first matrix here, and then we'll iterate through each of the numbers in that subarray here. Now we'll take this result here at index at subarray I at index j here, and we'll add to it the value of our second matrix at the subarray index I at the element index j. That should give us our solution matrix here. Let's go ahead and test this out here. We're going to go ahead and pull this right here, and we're going to do a console.log. And this should give us a matrix 3, 4, 4, 6, 4, 4, 2, 2, 4. Let's go ahead and test this out here. 3, 4, 4, 6, 4, 4, 2, 2, 4. And let's go ahead and punch this into Codewars and see what this looks like here. It's an attempt, and we are good. Now, another way to implement this kata solution without resorting to copying arrays would be to use the array object's map method. First, we take the matrix itself and run that through the map method, and we'll get the subarray out of that and its index here. Next, we'll take that subarray and run it through the map method, pulling the element out and its index there too. what we'll do, we'll return the element plus the element of the second matrix at the indices that we get from the mat method's predicate functions here. That should give us the same response that we have in our Kata solution here without resorting to copying arrays. Here we are tasked with creating a variable length vector class which supports addition, subtraction, and the dot product and normalization. Alright, here we have our vector class right here. The class has a constructor which takes an array of numbers. Note that this vector is capable of taking arrays of variable lengths. Alright, and we have the class's methods here: add, subtract, dot, and norm. Alright, let's go ahead and give this a try here. I'm going to hit train. Alright, we are going to have our class vector here. Alright, first our constructor here is going to take our components. Okay. And we are going to have a couple members here. This dot components equals components. And we are also going to keep track of their length too. Alright. We're going to go down here and we're going to go ahead and create an couple instances of our vector class here. We're going to go ahead and grab these here from the Kata instructions. New const instead of var. Alright. Let's go ahead and first, let's do the toString method here. And this obviously will return a string representation of our vector here. So what we'll go ahead and do is let result equal, actually, let result equal a blank string, and we'll return a template string with that result down here. And what we'll go ahead and do here, oh, wait a minute. What we can just go ahead and do is return our template string, and then this dot components dot join together with a comma separator here. Alright, with that implemented here, let's go ahead and console.log each of these here. And let's run this through Node and see what this looks like here. We need to run these through toString. And we have the string representations of our vectors here. Alright, let's have a look at the test cases here. Yeah, and we also need a method for comparing vectors to see if they are equal. So we'll do this method here that says equals. And we'll pass in the other vector as a parameter here. And what this should do, we're gonna go ahead and first check to see if they have the same length. If they don't, we'll return false. Now, I wonder if we need to do any type checking here. Do we need to do any type checking? I imagine we will. So if type of other is not equal to vector, then we return false. Now, would like to console.log type of A. Let's see what that looks like here. Object. All right, never mind that. Never mind that then. Okay. All right, but that being said, let's go ahead and iterate through each of the components of our vector here. For let I equals 0, I is less than this dot length plus I. If this dot components at I is not equal to other dot components at I, then we'll return false. I have another idea. Check to see if this is actually a vector. If not other dot length, if type of length is not equal to a number, or type of, or rather, if type of other dot length is not equal to number, or array dot is array other dot components is equal to false. And then return false. That way we can do some type checking here to make sure we're actually comparing vectors here. Anyway, if we reach the end of this for loop without this returning false, we can go ahead and return true. All right. Yeah. Okay. All right, let's go ahead and implement our other vector methods here. So we'll do add. We'll pass in our other vector here. Now, the Kata instructions state we have to throw an error if we attempt to add or subtract or dot product two vectors with different lengths. So if this dot length is not equal to other dot length, throw new error. Attempt to add vectors of different lengths. Otherwise, what we will go ahead and do is I think what we go ahead and do, does this modify? No, it should return a new vector. Okay. So I think we'll go ahead and we'll create a new array. With this many elements, this dot length and number of elements. We're going to go ahead and return a new vector with that new array in its constructor here. And what we'll go ahead and do is for let I equals 0, I is less than this dot length plus I, new arr at index I equals this dot components at I plus other dot components at I. All right, we should be able to do the same thing with our subtract method here. I'm gonna go ahead and clean this up a little bit here. Subtract. Instead of the plus here, we'll do a minus here. All right, next is the dot product. Now, what we should go ahead and do here, we're going to do dot other. And we'll do just as we did in the add and subtract methods, we need to throw an error if the lengths are different. Now what we need to go ahead and do is we'll keep track for the dot product. We'll keep track of a result here, and that's going to be what's returned. We're going to go ahead and iterate through each of the components of our vectors here. For let I equal 0, I is less than this dot length, plus plus I. And what we'll go ahead and do is result plus equals this dot components at index I times this dot, or rather other dot components at index I. And that should get us the dot product of our vector here. Next, we need to normalize our this. You know what? This looks more to me like the vector's length. So what we'll go ahead and do is we're going to create our norm method here. And what we'll go ahead and do is we'll return math.s, or rather, let result equals 0. And what we'll do is for let I equals 0, I is less than this dot length, plus plus I, do result plus equals this dot components at I raised to the power of 2. And then we'll go ahead and return math.sqrt, the result, the square root of the result here. All right, I think what we can go ahead and do now. All right, let's go ahead and sample some of these tests here. I think we're all done with that. Let's go ahead and punch this into Codewars and see what this looks like here. First, let's go ahead and run the tests. That one test passes. All right, let's hit attempt, and we are good. Now, I do have a little bit of an issue with this kata here, and that is in the implementation of the norm method inside of the vector class. Now, this method called for us to take the components of the vector, raise it to the power of 2, and then return the square root of the sum. By doing so, you're actually getting the length or magnitude of the vector. There is a difference between that and normalizing the vector. To normalize a vector, you do get the length of the vector, but then you have to take the components of the vector and then divide it by that length. Given a size, the goal of this kata is to return a two-dimensional square array of that size, such that its elements form a clockwise spiral that looks something like this, assuming a size of 10. The dots in this diagram will be represented in our two-dimensional array as a 0, and the zeros in this diagram will be represented in our two-dimensional array as 1. Alright, let's go ahead and give this a shot here. Alright, see how we implement this here. First, I see us keeping track of a position here. Const position. We'll set that to an object with properties x and y. Something like the vector class that we did in the previous kata. Alright, let's go ahead and I think we'll need to enumerate our directions as well. Do const directions. I think we'll start with right. Then we go down. And we go left. And then we go up. Alright, what I think we'll go ahead and do is we're going to go ahead and keep track of our current direction. We'll set that equal to directions.right to begin with. I'm going to move this up to the top of our function here. Alright, now what we need to go ahead and do, we need to make our array, our square array of this size here. And we will do that by doing this. Const spiral equals new array. We're going to create a new array with our number of elements that we specialized in our size parameter here, and we're going to fill that new array with another new we're going to fill that new array with new subarrays of that size, and we're going to fill those subarrays with zeros. Alright, now we have our spiral all created. This is going to be what's returned. Let's go ahead and console.log that and see what that looks like here. Let's do length 5. Let's do node spiral. And that should give us an array of 5 subarrays. Each subarray has 5 zeros in it. Alright, let's go ahead and get to the meat and potatoes of this kata here. Now, if you look at this spiral diagram, you'll note that I think it traverses 5 times. 1, 2, 3, 4, 5. I think what I can go ahead and do is we can iterate through this 5 times here. Let's I equals 0, or let's call it index equals 0, index is less than size plus index. I don't think we'll be using that index at all though, so just rename that an underscore here. Now, what I think we can go ahead and do is we need to check to see what our current direction is first. If direction is equal to directions.right, and we'll go ahead and repeat that for our other directions here as well. Do else ifs here. Right, down, left, and up. Alright, now after this branch of if statements here, what we can go ahead and do, we're going to go ahead and take our direction, and we're going to set that equal to direction plus 1 modulo 4. So we add 1 to our direction, and then we divide it by 4 and get the remainder here. That way, if this would be a 5 as a result, this modulo operation would make sure we wrap back to 0. Alright. Now what I think we need to do we might need to have an inner for loop here. I think we'll do for. We won't have an initialization step here. Position.x, whoops, .x plus 1 is equal to size, or position.x spiral at position dot y Okay. We'll go ahead and do here. While position dot x plus 1 is not equal to is less than size. And what we'll go ahead and do in here is spiral at position dot y at position dot x. We'll set that equal to a 1. And then if spiral at position dot y at position dot x plus 2 is equal to 1, then we'll break out of this while loop. Now, since we're checking the subarray at 2 positions ahead, we are going to need to make sure that that is within the array bounds here. So if position dot x plus 2 is less than size and that other condition here. All right, let's see what we're doing here. Yeah, I think then we'll go ahead and increment our position here. So let's see what this looks like here. Spiral is not defined. Spiral, S-P-I-R-A-L, S-P-I-R-A-L, S-P-I-R-A-L. Let's try that again here. All right, let's do console.log spiral. See what that looks like so far here. Oh, that's interesting. Is it filling that with the same array? Yeah, let's get rid of that plus 1 here. Now hold on 1 second. Okay, let's fill this array a different way here. For let I equals 0, I is less than size, plus I, spiral at I equals new array, size, fill 0. Again, spiral. Let's try that again here. Yep. Yeah, that was the issue there. Alright, let's go ahead and continue on with this here. Now let's implement the downwards direction here. Alright, while position.y is less than size, spiral at position.y at position.x is equal to 1. Let's go ahead and get rid of this console.log up here. And then just like above here, if position.y plus 2 is less than size and spiral at position.y plus 2 position.x is equal to 1, and we break. And we increment position.y. Alright, let's... Spiral, again, is not defined. I don't know why, but we keep misspelling spiral here. Alright. So far, so good. Alright, now, let's do the leftward direction here. While position.x is greater than or equal to 0, spiral at position.y at position.x is equal to 1. If I think it's position.x is minus 2 is less than or equal to 0, and spiral at position.y, stop it, position.y, position.x minus 2 is equal to a 1, then we break. And then we do position.x minus minus. It's see what that looks like here. Cannot set property 5 of undefined. Okay, let's go ahead and console.log our position here. X5 and Y5. Ooh, see a little bit of a problem right there. I suppose we could go ahead and check that here. Position.x plus 1 is less than size. And repeat that here with our y here. And then over here, if position.x minus 1 is greater than or equal to 0. All right, let's try that again here. And it seems we have an infinite loop here. What is going on? Maybe get rid of this here. Maybe get rid of this here too. Of undefined. Maybe we need to Yeah, okay, 0, 1, 2, 3, 4, 5. If position.x is equal to size, then position.x minus minus break. I think we'll go ahead and repeat that with the second case of our y case here, our down case. Alright. We're almost there. Alright. Let's go ahead and decrement our position.x here. And if position.x equals -1, then position.x plus plus, then break. Almost there. Now we need to handle the up case. Alright, what we can go ahead and do, similar to what we did here. In fact, we'll go ahead and copy this and paste it here. While position y -2, and then we'll do our position y here. Theoretically, we probably will never get to this part of the loop here. Position.y. Alright, let's test this out here. And hey, would you look at that? We have a spiral here. Alright, let's go ahead and get rid of this console.log right here. Let's do a spiral 6 here. Make sure this is working as well as we expect it to. Spiral 7. I think we got it here. I think we have got it here. Spiral 100. Alright, we're going to go ahead and... Where did I put that console.log? Oh, never mind. Where did I put that console.log here? I know I probably got a console.log. Nope. Alright, never mind. Alright, let's... I hope this is good. Let's go ahead and try punching this into Codewars to see what this looks like here. Alright, let's go ahead and run the tests. And we are good. Boy, was that ever a heavy lift. It feels really good to wrap up our 30th episode of Versus Codewars with a 3 Kyu Kata. Here's the thing. Once you get into these higher Kyu Katas, your 3s, your 2s, and your 1s, it's always a good idea to plan out how you are going to implement your kata solutions here. Instead of rushing in guns a-blazing, like I typically do with the warm-up katas and the 6 and 5 and 4 Kyu Katas I've been doing in prior episodes. It's always a good idea whenever you're writing an application, a program, a book, a song, what have you, to plan out what it is you are going to write. This is a crucial skill for many trades, including web development and computer programming. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comment section below. Also, if you are a kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comment section below as well. And you might see me take on some of these katas in a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.